Okay, so in my previous video, I showed how to use the core Machina library in Visual Studio to be able to, to generate the program, stream instructions in real time to the robot, and then listen to the state of the robot and respond. Everything in real time, right? However, there's a tiny problem with what I've shown you before, and it is the fact that because it's using the main core library, which is written in the .NET framework, then basically you would be constrained to use this to control robots this way only in frameworks that accept some form of C# .NET components, which is not too bad if you're using Windows and depending on which software you're using, but it's a little bit constraining. So in order to be able to actually use these same techniques and this same control model from any platform or from any device or from any programming language that you can think of, we came up with a small bridge application that is really helpful to control the robot in real time from virtually with any language, programming language, or with any device that is connected to the network of this same device. So if you go to the robot, the main group of repositories, you can see that here the first one right now is called the Machina Bridge, and the Machina Bridge, this is extremely under development right now. So hopefully when you see this video, a lot of things will have changed for the better. But right now, this is like a really simple Windows application that has an UI that allows you and that simplifies all the process of connecting to a robot. And then it has like certain features that will make it really helpful to connect to the robot from virtually any environment that you can think of. So if you go to the project, you can always, as always, it's open source, so you can check the code, you can check everything. And if you go to the distribution folder, you will be able to download whatever latest distribution package. As of this video is 0.1. So I can download this to my desktop, for example. And if I unpack this, then that was not great. So let me just unpack this into a folder. So if I unpack it to a folder, what you can see now is that I have a list of files. This, for the moment, only works on Windows systems. But you can see that the main file is an executable. And then the rest of the files are just dependencies that this program relies on to work correctly, which is, among others, is the main Machina core library that we have seen in previous videos. So assuming I have a Robot Studio open in my system that has a robot with the PC interface option on, then basically this robot is as if it was connected virtually to the local network in which I am. If you have questions about how to set up Robot Studio for this to work, you can see my previous videos on how to do that. And then what we can do now is we can go back to this distribution folder that we just downloaded, and if I double click on the Machina Bridge, I get this window which is an UI that allows me to connect to the robot. Again, hope there's a lot of work that still needs to be done here, but I will explain over the basics of what's going on in a second. So here, for the connection, the main thing you need to do is you need to set a name for the robot and which brand of robot you're going to be connecting to. As of this video, it only works for ABB robots and universal robots. And then here, depending on which form of connection you're going to be doing, you will need to specify whether if it is the user who needs to handle the setup of the robot, or if it's Machina who will automatically figure out where the robot is on the network, upload the drivers, etc., etc. For ABB, right now, we can do everything automatically with Machina Manager, but for universal robots, you need to do everything. You need to you will see whenever you download this. Anyway, I'm gonna set Machina as the manager, and I'm gonna hit connect. And as I hit connect, you will see that the robot is being uploaded, the main Machina drivers, and is running now a server that is listening for actions from the bridge app. Everything happened a bit silently because I'm still working on the console and a window with like a buffer of actions that will show here. But anyway, we can see that this changed to disconnect, which means that we have successfully connected to the robot. And the robot is now listening to actions. So I'm going to move this a bit down here. And you can see that here I have this sort of like console that you can think of this as like a live connection with the robot. So here I can actually go ahead and write Machina style instructions, very similar to the ones that we would use in Visual Studio. So for example, here if I want to move the robot to the positive quadrant, remember that when the robot starts, I need to so I'm just going to say move to 400, 400, and 400, and then the robot is going to move to points coordinate 400 and 400, 400, right? However, remember that by default the speed is really slow, so what I can do is I can set the speed to a much larger value, like 200, and this instruction got sent right away to the robot, and I can now move the robot relative in y direction, so minus 800 for example, and then just make it move all the way to the negative quadrant as soon as it reaches the target, right? So is it going to do it? Let's see. Yep, so it reached the target and it's sped up, and now it's moving all the way to that coordinate. So I can, for example, move it in. I can, for example, move it up in the C direction, for example, 200, right? And it will move up. I can move it down, same thing, minus 400, and I can move it in the positive Y direction, and it's going to do its thing. I can, for example, I can rotate around the Y-axis, so that's the Y-axis and minus 90 degrees, and then it performs the rotation, and then I can bring it back home by setting the axis to 0, 0, 0, 0, 90, and 0. So as you can see, this is a very convenient and easy way of streaming actions right away with this sort of interactive console that accepts commands that are styled like Machina actions, like the ones that you would use in the core library. So this is quite convenient for quick operations and quick like connecting to the robot and like moving it around a little bit. This that I'm showing you with a virtual simulation in Robot Studio works exactly the same with a physical robot. So this is nice for like really basic stuff. But what's interesting about this application, this app, is that under the hood, very silently, what's going on is that this application has also started a WebSocket server, and that can be accessed by any device or any program in my local machine, or it could be accessed remotely by other computer on the same network, where the server has this address here. It has the address of the local host. The port right now is 6999, and the path is what's called bridge. Okay, which means that there is a WebSocket server living in my machine right now that is listening for incoming client connections, and whenever a client connects, the client can send to this server, can send instructions with the exact same styling as the Machina API, and then those instructions will be bounced, those instructions will be bridged into the robot and then will be executed immediately. So how does that work? We're not going to get into WebSocket programming here. I will actually write a link here to another video, another tutorial on how to do WebSockets. But in the same project that you saw the Machina Bridge, if you go to the main project, you can see here that there is a sample client. There's an example written in Node.js on how to connect with a client to a WebSocket server, and then how to send messages to that WebSocket server. So if you download the whole repository, or if you clone it, then you will be able to, you will have here in the sample client, you will see that there is a WebSocket client.js file, which is a Node application that so let's double click on this one. So if I open it, and again, also I'm also going to post a link to how to write Node.js. Basically, what we have here is a WebSocket package that is connecting to the same WebSocket service that is running on the Machina app. So, and you can see here the address. This is the same, right? I have created 2 event handlers when you open the socket and when you send a message. Sorry, when a message is received. When a message is received, it's just going to be plotted. It's just going to be written to the console. Okay, and then you can take a look. You can take a look at this, but this is basically a way of creating an interactive REPL, an interactive terminal in Node, where I can write commands in Node, and then those commands will be streamed to the robot. So, for example, if I write exit, the app will terminate. If I write home, then these 2 messages will be sent to the WebSocket server, aka the Bridge app, right? If I write square, then this array of actions, so speed, transform, moving, etc., all of these will be sent to the robot. And if I write anything else, then that action, that command, will be streamed directly to the robot. The way to run this is opening a terminal here in this same folder, and very likely you will have to run npm install so that you have the most updated version of all the modules that this project requires to work with. And then I can say node WebSocket client, and then I will start my WebSocket client with a connection that has been established to the Bridge app. It doesn't show up here, but it should show up at some point, and also some message here in the console should show up. But basically, my Node application is connected as a client form to the web server, the WebSocket server that is running in the Bridge app, which means that anything that I write here is going to be sent to the Bridge app, and the Bridge app is going to send it to the robot here. So, for example, let's say that I type move to 300, 300, 300, then something should happen. Let me type square. You can see that because I typed square, and square has like all these actions, and you can see that it's starting to trace all those actions. And you can see also that the WebSocket server is responding with a message that reads action completed. This is very similar to the event handling and the event description that I described in previous examples, and it also tells me how many actions are left. So now here I can probably just type move to, I don't know, like -100, 0, and then this is going to be streamed to the Bridge app and back to the robot. I can probably type axis to, I can probably move it up, so 0, 0, 200 in the Z direction, and it's going to move up. I'm going to move it down, so 0, 0, -400 and 0. And you can see that actually I got an error right now because I moved it too far up, and then one of the joints is out of range. So the robot cannot reach that position. The joint that is out of range is the 5th axis. It's too bent inwards here. So if this happens, something that I can do is I can just stop my client. I can probably disconnect from the bridge. I can connect again to the bridge. And then here, I'm going to start my client again, WebSocket client, and then and type home. And home in my client is a predefined program that I wrote where I just sent two instructions, speed and axis, right? So yep, that's pretty much it. So what this means is that I can create any WebSocket client in Python, in JavaScript, in processing, in Grasshopper, Dynamo, whatever you can think of. I can connect to this bridge app, and any string message that I send to the bridge with the form of the API of Machina then will be understood by the bridge and will be streamed to whatever robot you have connected right in that moment, either physical or virtual. So I can now just disconnect and close the application, and we're good. So this opens up the door for any device potentially controlling and sending instructions to the robot and receiving acknowledgements of actions completed, or like the position of where the robot is at any given moment. Okay, so thank you very much, and stay tuned for more videos.